Okay, the last type of bonding we need to look at is metallic bonding. Metallic bonding, although we spend less time on this than on the other types of bonding, is perhaps the most special. Very simple at first glance, and it gives this kind of bonding gives metals some amazing properties. They really are strange materials and they do wonderful things. The first thing to get your head around is the idea that each of the atoms in the metal gives electrons, its valency electrons, or the outer shell electrons, it gives the electrons to what's called the delocalized sea of electrons. So it donates electrons to this sea of electrons that flows between, well, because they've lost electrons, the ions. So it flows between the ions. So each atom gives up its valency electrons, it forms an ion, and the sea of electrons flows around the ions. And those ions are in a lattice. So there's a structure, there's a lattice, a regular arrangement of the ions, and you have a lattice of positively charged metal ions surrounded by the sea of delocalized electrons, the mobile electrons. Okay, I hope that's clear. Now, of note, once you have the metal ions and you have this sea of negatively charged electrons, then obviously the two of those things attract because opposite charges attract. So the thing that holds this material together, this metal, is the attraction between the positively charged ions and the sea of electrons. And that's what metallic bonding is. Interestingly, it acts in all directions. So this positive ion is attracted by all of the sea, wherever the sea may be, all around it. And the same goes in reverse. The sea is attracted to all of the ions. So there's no direction, it's all directions. This attractive force is in all directions, and that gives some special properties. Let's try and use these initial ideas, this basic concept of metallic bonding, to explain some of the properties. So, why do metals conduct electricity? Well, they conduct electricity because the delocalized sea of electrons are free to move. If I apply an electric field, so these electrons are shooting around randomly, if I apply an electric field across the metal, then if this is the positive end, this is the negative end, then the electrons, well, which way will they be attracted? They're negatively charged, so they'll be repelled by this end. They will shoot in the direction of the positive charges, won't they? In this electric field, the electrons will shoot in that direction. Okay, they move towards the positive and away from the negative. So that's why metals conduct electricity. The mobile electrons, the sea of electrons, is free to move. Why do they conduct heat? Well, they conduct heat because these ions that are fixed in the lattice, when they vibrate, they can pass the vibrations through the structure. So the ions in the regular lattice pass the vibrations of heat energy through the structure. The electrons can also pass energy. They can also vibrate and they can pass energy through the structure too. But it's mainly the fact that the ions exist in this regular and very closely packed structure. The ions exist and they pass on the heat energy. Why are they malleable and ductile? Well, the layers of ions can slide over each other and adopt new shapes. So these are the ions, and that's the sea of electrons. And when you hit them with a hammer, what happens is the ions move, the top ions will move, and they'll adopt a new position. So the lattice changes shape. But once it gets the new position, it holds together because the force of attraction between the positively charged ions and the sea of electrons is still there. Okay, so this is really to do with the idea that the metallic bonding acts in all directions. So if you move the ions, the bonding kind of adjusts, but it holds the material together. If you pull them hard, these ions will form a line. And this is called ductility, isn't it? If you pull on the ends of some metal, it will be drawn into wires. So you can make metal wires. Typically we do with copper. So copper atoms can form metal cables and wires by being stretched. So they're malleable and ductile. Other properties of interest. Many have high melting points and bonding points. We know exceptions, but generally they do, because the bonding, metallic bonding, is quite strong, so lots of energy is required to overcome it. And also many of them are hard and dense. We know of exceptions, but many, you think of lead, or you think of iron, or I'm going to say steel, but steel is an alloy. But if you think of metals, generally lots of them, the transition metals especially, can be hard. Okay, have a look at the pages indicated and do the questions, and then also you are ready for the end of chapter summary questions and practice questions.